Ester. Ester are sweet-smelling carbon compound. They widely used as a fragrant because they have a nice smell and they are non-toxic, which been used in cosmetics and food industry. And natural flavor of food usually have different type of ester, and many flower also produce ester and giving the nice smell. If you look onto the shape of ester, you will see a C double bond O in the middle, C double bond O, COO, and this is called the ester bond. Certain nice type of smell like banana smell, apple smell, orange smell, pineapple smell, they all are made from ester. Ester are a volatile liquid and with such a pleasant smell. What's meant by volatile? That is easy to turn into gas. Ester usually are a liquid in room temperature, and it have a low boiling point and easy to become gas. We're going to look onto the intermolecular force of dispersion force and dipole-dipole of this ester. Let's look onto the structure of ester. Ester, they will have a C double bond O in the middle, which is slightly polar, because C and O are not symmetric. So they are slightly polar in the middle, and the rest is made of a hydrocarbon non-polar molecule. So the attraction force between this molecule going to be dispersion force and dipole-dipole. I show example. Hydrogen bond must contain a OH, NH, FH. You look onto ester, COO. They are polar, but they are not OH or NH. They are only partially polar, so they are not hydrogen bond. And they are belong to this dipole-dipole, which is partially polar. So they forming dipole-dipole between molecule. And for this hydrocarbon group, they form disperse force because as being a non-polar molecule. So ester, they bonding with the neighbor molecule through dipole-dipole and disperse force. And these two types of bonding, they have a low boiling point. That's why to make it into a liquid that easily become gas at room temperature. Ester is made of carbonic acid and alcohol. Carbonic acid with alcohol form ester and water. Catalyst required, sulfuric acid. Now let's look onto alcohol. We learned on early chapter alcohol. Alcohol have a OH group. 1C methanol, 2C ethanol, 3C propanol, 4C butanol, position 2, 2-butanol. And this part with the OH group as the function group, student already learned. Now let's turn to acid. This is called alkanoic acid. Student, is the first time that you come across. Look at it carefully. You have two function groups. The functional group have made of two parts. You will have a double bond O and a single bond OH. Like methanoic acid 1C, double bond O and a single bond OH. Ethanoic acid have a double bond O and a single bond OH. Propanoic acid, double bond O, single bond OH. Butanoic acid, double bond O, single bond OH. Student, please learn this double bond O, single bond OH as an alkanoic acid. So, student, out of the carbon structure, you will learn the alcohol as well as alkanoic acid. Now let's look more detail. What's this double bond O and a single bond OH make different? We look back onto the alcohol, the one that we're familiar. All the alcohol, it have a OH. Of all the alkanol, you have a OH. So they form a hydrogen bond between neighbor. So this alcohol with a OH and with the other alcohol with a OH, they forming hydrogen bond between neighbor molecule and give them quite a high to medium boiling point. They're much higher than those non-polar molecules. Now let's look onto the alkanoic acid, which you have a C double bond O and a single bond OH. And they form more hydrogen bond between neighbor molecule. Look at this, C double bond O and a single bond OH. Another molecule, C double bond O with a single bond OH. And it form more hydrogen bond than the early example. So they form more hydrogen bond and make it to have a higher boiling point. I'm going to look onto the graph to demonstrate this higher boiling point form because of this more hydrogen bond. Now I'm going to show three lines. Earlier we learned alkane. What is alkane? Hydrocarbon. Hydrocarbon are a non-polar molecule. Between them they form dispersion force. So the boiling point are low, between -100 to 0. Alcohol, you have a OH. You have a OH, so you form hydrogen bond, which your temperature raised by 100 degrees more. Now we learn the alkanoic acid on today's topic. They form more hydrogen bond. More hydrogen bond cause it to have an even higher boiling point than alcohol. So student, please understand this intermolecular force interaction affect the boiling point of the physical property. Ester, it divides into two parts, structure and name. Let's look structure. You look onto the ester. Some students get confused because you have two O, which is which? The first double bond O belongs to acid because only acid contains double bond O. Second O belongs to alcohol. Student, HSC will ask you in flip into upside down, back to front, left to right to confuse you. So you must be able to identify properly the structure, like the first one. Acid part, first double bond O is the acid. 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 Then you can do the naming. Naming rule. Divide into the first part, alcohol, second part, acid, then OATE. Now we do example. First example. You identify which part is the acid, which part the alcohol. This part is the acid, 2C acid, 1C alcohol. So 1C alcohol, what's the name? Methyl ethanoate. Another one. Acid part, double bond O, 3C acid, 1C alcohol. Naming rule, alcohol first. Methyl propanoate. Another example. 4C acid, 2C alcohol. What's the name? Ethyl butanoate. So student, first analyze the acid and then the alcohol. All structure acid must have a double bond O. And then the naming rule, alcohol first. We do a more example. What's the name of first one? Methyl ethanoate plus water. Next. Ethyl methanoate plus water. Ethyl benzenoate plus water. Now, we're going to talk experiment. The experiment is called reflux. If you study this experiment, you soon realize there's something special. You will have a very long neck jar. This long neck jar, this part, this is a condenser. Water go in to cooling the wall of this tube and the water coming out. Water go in to cooling the wall of this tube and then the water coming out. The water doesn't go inside the tube. This is only to cooling off the tube. This is the condenser function. Remind you, what is ester forming? Acid plus alcohol form ester and water. This forming called esterification. Acid plus alcohol at room temperature does not react. You need to raise temperature high enough around 200 degrees to make this reaction happen, and with the help of sulfuric acid. If the temperature not high enough, no reaction will take place. But there is a downside. If you raise 200 degrees, those acid and alcohol will all evaporate. They are quite volatile. So if you do at high temperature, they will turn into gas. At low temperature, they don't react. So you lost in both sides. And that's very difficult. How are we going to make esterification? The trick is this reflux. By using this reflux, you are allowed to do this esterification at higher temperature, which you can increase the rate, make the reaction faster. Then you ask, what happened to those unreactant gas? They will also evaporate. And those gas will be recondensed by the condenser and will back onto the vase for further reaction, as I'll show you on the picture. You can see that is an acid, C double bond O and a single bond OH. Alcohol, OH. Through sulfuric acid, it should be react as follows. Now the ester form at 200 degrees. But you will find a lot of unreactant acid and alcohol. They evaporate before the reaction takes place. So, through this long neck apparatus, this condenser, they will be recondensed. So, now they will recondense back onto the jar and will react again. So, that is the function of this condenser. Safety precaution. You have to realize of this experiment is different from your early experiment. This experiment have danger in it. Why? Think about what's inside this bottle. This bottle inside is a pure alkanoic acid. What else? Pure alcohol. What else? Concentrate sulfuric acid as catalyst. Alcohol is quite flammable. It will catch fire at 200 degrees easily. So once they catch fire, the experiment will be very dangerous. So there is a lot of precaution you need to do. You need to put some boiling chips inside this round jar to promote an even heating. Secondly, even more important, you cannot put a direct heating onto this round bottle. Because direct heating onto this bottle, you raise the temperature too fast and the alcohol will catch fire. So you must using a water bath to make the heating even, to raise temperature slowly. Otherwise, it is flammable and inside content are very dangerous and the temperature are very high. So student, you have to understand the molecular structure, the chemical reaction, and the experiment, as well as the safety precaution.